My name is Stephen Fuselier. I'm a research scientist at Lockheed Martin. I've been working on the MMS program since its inception. And my job on the MMS program is to try to figure out which orbits we should put the spacecraft in order to maximize the science return. And the way we do that is that the Goddard Space Flight Center Flight Dynamics group, that is the group that decides on how much fuel the spacecraft require to do their orbits, sends us some preliminary orbits which they've calculated, and then we take them and run them through our models of where reconnection occurs, and then figure out what's the probability of detecting these reconnection regions that we do that. And through that process, we've been able to decide on a set of orbits that very nice, gives us a lot of reconnection regions. In fact, so many that it gets to the point where we can't bring down all the data. And so now we have a problem in that in a particular orbit we may get many nice events, and we don't have the telemetry, that is the way to the bandwidth to transmit the data to ground for that orbit. And so now we have to put on the spacecraft some smarts. And the way we do that, we have a trigger, which is called a burst mode trigger, that is to go into taking high data rate for an interesting event. And we develop these burst mode triggers by our ability to recognize a reconnection event when we see it, from looking at past spacecraft data. And so we use onboard to the spacecraft, the instruments provide data to this burst mode trigger algorithm that works inside a computer and calculates in real time what it sees, and says and basically tells the spacecraft is seeing something very interesting. Please go into burst mode and gather the data together for that particular interesting event. And then on the ground, we hope we take a look at the data and we see how well it's done, and maybe go on and change the burst mode and change the algorithm on the fly. Let's say on the next orbit we make modifications to that and gather some new data. So what fraction of the data is it that we can send down? It's actually a very small fraction of the whole orbit, which takes about a day. We can send down, in fact, only 20 minutes of data at this very high data rate. And so that means that we have to be really quite smart about where we pick our data to send down. Yeah, the nice thing about that, the mission is that if we have a boring orbit, we can pick data from a previous orbit. Let's say we have an exciting or more exciting orbit, the previous orbit. We can pick more data from that and bring it down at the expense of a later time.